Hey everyone, in this video I'm going to be making an answer key for the Unit 7 Homework 1 problem set. So let's get right into it. So for part 1, let's take a look at the question. We have to look at the directions. It says determine if each of the following questions is a statistical question or not, and if the question is not statistical, then rewrite it so that it is one. So for question 1, that says how old is that 6th grader? This is not a statistical question, so I'm just going to write not statistical. And how could we rewrite this? Maybe we can say, how old are all the 6th graders? All the 6th graders. Maybe we can say in this class. In this class. All right, so as long as we're asking multiple people and we can collect data, just like that, we can turn it into a statistical question. So that's number 1. Okay, let's look at number 2. How long can each of the 6th graders hold their breath for? Well, if we're asking a bunch of 6th graders, then this would be statistical. So you don't have to worry about statistical. You don't have to worry about whether if you have to change it or not. So if we're asking a bunch of 6th graders, that's good to go. That's number 2. Okay. Number 3, who is your favorite teacher? This is not statistical, so I'm going to go ahead and write that here. This is not statistical. We're just asking one person if we just say, who is your favorite teacher? Now, you could argue if you're asking this to a bunch of people, statistical, then it could be, but it's hard to always kind of know if you're implying that or not. So maybe we can just change this and be more specific to be extra clear. We can say, who are all of the students' favorite teachers. Students' favorite teacher. I'm going to say fave teacher. Okay, so the goal here is just to really specify that we're asking multiple people, and if you do that, then we're very clear that is a statistical question. Okay. Number 4, how many languages does each student in the classroom speak? If we're asking each student in the classroom, then yeah, that's statistical. Statistical. Always have trouble spelling that. So that one's good to go. Nothing to change there. Number 5, what is your favorite type of candy? Again, you could, I guess, assume this either way, but I think just to be safe, we can say this is not statistical. Statistical. We can say, what is everyone's favorite candy? So as long as we're asking a bunch of people, good to go. That would be a statistical question, just to clarify it. Okay. Number 6, what country was each student in the country born? Well, if we're asking each student in the classroom, then we should be able to collect a variation of data. Statistical. And that one's fine. That's a statistical question. So part 1, hopefully you felt like it wasn't too bad. Pretty straightforward. You just need to make sure you know the difference between statistical and non-statistical, and how one collects data for that could vary and is collecting data that is from, maybe more than one person, or from one person, but collecting a bunch of different type of data with that. So that's 1 through 6. All right, moving on to part 2. Part 2 is talking about shapes of distributions of data. So we have to answer each of the questions about how the shape of data can vary, or data can vary. So let's take a look at number 7. A statistical question is asked, how many cavities do each of the 10 6th graders have? Okay, we have 10 of these 6th graders. Draw a dot plot showing the number of cavities each of the 10 students have. If the data is right skewed, then we need to write one sentence at the end, concluding the overall health of the student's teeth. Okay, so first off, we are going to draw a dot plot, which means we're going to draw some sort of horizontal number line typically, maybe something just like this. And talking about cavities, maybe I'll start with 0 cavities. 1, 2, 3, 4, 5, 6, 7, something like that. Again, you don't have to start with 0. You can start with any other number. Depends on what you want to do. And maybe give it a title. So number of cavities. And it looks like we have 10 students, so we can put 10 X's or 10 dots. Maybe I'll use dots in this video, but again, it's kind of up to you. And they say it's right skewed. And just remember, if it is right skewed, then most of the data is going to be on the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe 10. So here we have 10 data points, and we can see that most of them are on the left side, so we can conclude that this is definitely going to be right skewed. So here is most of our data, and then less data is on the right side. So this is right skewed. Okay. As for the one sentence conclusion, because it is right skewed, we can make the conclusion that most of the students' teeth are pretty healthy, right? We can say most students have very few, if not none, cavities out of the students here. So we can say most students have less cavities. Cool. So just keep in mind, if it was left skewed, that means relative to the data set that the students had more cavities than less cavities. So here we're just saying that they probably have healthier teeth. We can maybe put that here too. That these students have, in general, healthier teeth compared to maybe other people. Healthier teeth. Okay, that's basically all you had to really say for number 7. Done. Okay, has to be right skewed. Number 8, a statistical question is asked. What do each of the 15 sixth graders score on a recent math quiz? We're going to draw another dot plot of each of the 15 students. If the data is left skewed, we'll write one more sentence here. Okay, so there are 15 sixth graders, and they took a math quiz. And I don't know, you can decide if you wanted them to all do well or all not do well. Maybe I can draw that a little nicer. I realize that's kind of crooked. Let's see here. I don't know, it's about the same. There, all right, whatever, we'll be okay. I don't know, maybe I'll put 90 as the highest grade here. And let's say maybe they were scored in intervals of 5 points each. So 90, 85, 80, 75, 70, 65, 60, and the lowest will be 55 for mine. Again, yours can be different. That's perfectly okay. And I'll put scores down here. These are going to be the scores for each of the students. And there's 15 of them, and it's supposed to be left skewed. So if it's left skewed, where's the data going to be? That means most of the data is going to be on the right side. So let's put 15 of these dots down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I guess we should make one more. I guess I can put someone down here. I'm indecisive. I'm going to put it right over here. Again, it doesn't matter. It's your choice where you really want to put it. And I think I used a blue curve. So maybe something like this. Okay, this would be what we're saying is a left skewed data set. Okay, so what does this mean? Well, one conclusion you can say here is that if the data was left skewed, this is actually a pretty good thing, right? If it's left skewed, most students did quite well. Most students did well on the quiz. That's a good thing, right? So hopefully it wasn't going to be right skewed. If it was right skewed, that means most of the data would be on the left and most students did worse. But because it's left skewed, the students did, in general, better. Okay, so that's a good thing. Moving on to number 9. A statistical question is asked, how many hours did each of the 10 students spend on homework each week? We're going to draw a dot plot showing the number of hours spent on homework by the 10 students. That is symmetric, okay, symmetrical. Then we're going to write one sentence at the end, concluding about what we can say once we have it. So, okay, we have 10 students, so I'm going to just draw horizontal number line just like this. And how many hours spent on homework each week? Well, I would think that most students maybe spend about an hour a day. So maybe I'll start at, well, I don't know, I can start at 0, go 1, 2 hours, 3 hours, 4 hours, maybe 5 hours, maybe 6. I don't know. I guess it depends what grade you're in, but in 6th grade, I think in general you're spending less than 6 hours a week at least. Depends how focused you are. I guess everyone's a little different, right? So 10 students, and it's symmetric. Okay, so if it's symmetric, Hopefully it makes sense that most of the data is in the middle when you're talking about symmetrical data. So I think 3 would be roughly in the middle. So I'll put 4 people studied for 3 hours. And then we can say a couple of people studied a little bit less. So that's 4, 5, 6, 7, 8. Maybe I'll put 1 here, that's 9. And I'll put 1 here, that's 10. Okay, so we can see here that the data is clearly mostly in the middle, and then it kind of tapers off as you go off on the side. So this is what we would call as symmetrical data. Okay, maybe a conclusion, or I forgot to write a title for this. So I'll call this homework hours. And I'm thinking here, what can we tell? Well, we can just say most students spent 3 hours on homework. Again, we're doing just one conclusion or one sentence. Spent 3 hours on homework. And we can also say, but, or maybe not, but we can say, and less did a lot more or less. Did a lot more or less, right? The idea here is that as you go farther and farther from the middle, less and less people did those sorts of numbers of hours, right? So only one student did no homework or 0 homework throughout the week. But we can kind of just see here that as we go farther away, it'd be less common for that to happen. And I would say this is pretty true, right? Most students do spend some time on their homework, maybe 3 to 4 hours, and some maybe spend longer for different reasons, okay? That's number 9. And we can move on to number 10. A statistical question is asked, how many languages does each of the 30 students speak fluently? Okay, it's 30 students and speak fluently. State whether you would predict the data to be skewed left. We have to decide here, skewed left, skewed right, or symmetrical, and explain why. Okay, well, you don't have to draw anything. There's no direction that say that, but I'll draw a general idea here. So, well, most people I know speak one language, right? Whatever their main language is. And let's put 2 languages, 3 languages, 4, 5, 6, 7. So I guess the question is, where do you think these people would be spread out in terms of how many languages? So I'm going to write number of languages. I think I spelled that right. And I don't know, do you think most people speak more than one language? So I guess that's the question you got to ask yourself. But I would say that, most people speak either 1 or 2 languages, right? So let me go ahead, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, something like that. I mean, I don't, to be honest, know how many people speak more than maybe 1 or 2 languages. So I think as you go higher, it becomes more and more rare. Again, for like 7 languages, I don't know anybody personally that speaks 7 languages fluently, let alone 6 or 5 or 4. Those are also quite unlikely. You'd have to be pretty, well versed with a bunch of different languages. So I would say that most people do speak 1 or 2. Like I personally speak 2. I can speak Mandarin and English and maybe a little bit of Spanish, but I wouldn't say I'm fluent in it, right? So I would say most people probably speak 1 or 2, and then less and less as you go more. So what's this shape called? Well, we should go ahead and call this one, most of the data is on the left, so we should call this right skewed. This is right skewed data. Okay, and then we need to explain why. Well, I think I kind of just touched upon it a little bit. I think it'd be right skewed, and we can just say something like most people speak 1 or 2 languages. And you could write more if you want to, but I think the idea behind it is saying most people speak 1 or 2, but less and less would speak 5, 6, or 7 languages. Less common. Okay, that's all you had to really do for this one. And I sketched it just in case it helps you visualize and understand why it should be right skewed. Number 11, a statistical question is asked twice, okay? 2 times. How many bathrooms does each of the 30 students have in their home? So there's 30 students have in their home. If the data is left skewed when asked in one school district and right skewed when asked in another school district, what is a conclusion you might come up with sorry about that, with about the 2 districts based on those distribution shapes? Okay, so there's 2 scenarios happening here. So maybe one scenario looks something like this, and I'm not going to make this very detailed, but the first one talks about, maybe you can say you have 1 bathroom, 2 bathrooms, 3 bathrooms, 4 bathrooms, and 5 bathrooms maybe. And let's go ahead and do the same thing over here. Say 1, 2, 3, 4, and 5 bathrooms. And they say that if you go to one school district, it's left skewed. So that means most of the data would be on the right, maybe something that looks like this. And then it says that the other school district is right skewed. So that means most of the data is on the left, and then there's less as you go more and more to the right. So what's the difference between these 2 school districts? So maybe in one school district, we could say that these actually had maybe bigger houses or bigger homes. And why would that be the case? Well, if they asked 30 random students and they all responded that most of them had between 4 and 5 bathrooms, well, more likely than not, you have more bathrooms, your house is bigger and just has more rooms in general. And over here, you would maybe be able to assume that if you only had 1 or 2 bathrooms, that you might be living in an apartment or a really small house, right? So that is maybe one conclusion you could make. You could also maybe say you on the left here will have more expensive houses, and then on the right side, when you have less bathrooms, you have less expensive houses, right? So if a home has more bathrooms, it's more likely to cost more on average. Okay, so that might be a conclusion you could make here, okay, with the distribution shapes. That is number 11. Okay, finally, looking at number 12, give 4 different scenarios where you would expect the distributions to be left skewed, okay, and then right skewed, then symmetrical, and then uniform. Write 1 sentence for each scenario explaining why. All right, so we didn't talk about uniform too much, but that's not too bad. We can talk about it. So maybe for left skewed, I'm going to abbreviate LS for left skewed. And what's a situation where we would want the data to be mostly on the right? Mostly on the right. I think that would be what would be good for that. So maybe just test scores, right? I know I did an example earlier, but I would probably want them to be on a left skew. So my test scores I would hope would be good or higher on typically. So that would be something I would want to be right skewed. And for the sentence for that, I can say something like, I want to do well, or I want to score well. Okay, so that's being left skewed, but we also could be right skewed, right? So if we have right skewed and most of the data is on the left, what might be a scenario where we would have that? Maybe say car accidents, right? Car accidents. So if we have a right skew, that means most of the data is on the left. So maybe that's less car accidents. I want to be safe. So I know I'm obviously like simplifying this a little bit, but I'm basically saying here that if the data is mainly on the left, that would be a good thing if it was right skewed here, and because that means that you're getting in less accidents in this scenario. So I would just want to be safe. I wouldn't want to be in many accidents. So I'm trying to just say here that I would hope that that data is right skewed for most people driving a car. Okay. The next one is going to be symmetrical. I'm just going to write SYMM for symmetrical. And where might that be distributed? Kind of like the same. I don't know, just like heights of people, right? If you were to do the randomly and you randomly chose people, and you found out all of these people's heights, and why would the height like maybe be uniform or symmetrical? Well, if you think about it, if you grab random people, and you're not, if you go to like a basketball team and ask them all for their heights, then they're all generally going to be quite tall. Or if you were to go to a horse show and, they're having a competition with races, typically jockeys are going to be a little bit shorter maybe, right? So there's a big difference between those types of people. But on average, if you're going to go around and ask people, you're going to end up getting some tall, some short, maybe some really, really tall, some really, really short, but most people will be closer to the average height. So I can just say like this should be random, right? This should be random. So there would be some bias in our data if we asked like a bunch of athletes or, very tall athletes. But if we just go ask randomly, we should get kind of this symmetrical distribution of, most people being the same height and someone maybe freakishly tall or freakishly short, or just really tall, really short. I don't know. But either way, that would be more rare for someone to be very, very short, and it would be rare for someone to be very, very tall. Okay, you wouldn't really want, if it was random, for it to be much different than that on average for a random sample. Last one is uniform. So if we say uniform data, if you don't know what that looks like, uniform data is just like if you were to draw a number line or a dot plot and you had your numbers down here, so like 2, 3, 4, 5, 6, 7. And this is just where you have like the same number of dots all the way across, right? So it's not skewed left, it's not skewed right, it's not symmetrical. It's got basically the same number of data points across the entire dot plot or number line. So this would be an example of uniform. So where might that be the case as well? I don't know. Let's think. Where might data be uniform? And just as an example, what could it be? So this could just be maybe rolling a dice. Rolling dice. And maybe the numbers here would be like 1, 2, 3, 4, 5, 6, right? So you would roll a bunch of 1s or 2s or 3s or 4s or 5s or 6s, but there's equal probabilities, right? So you would expect that a 1 on a dice would roll just as frequently as a 2 or a 3. If you just have one dice, there wouldn't be any reason why one should happen more than the other. So maybe I can just say equal or equivalent, equal probabilities. Right? So that's important to kind of understand. So like if it was rolling a dice, you would expect every number to have same probability. So nothing would happen more than the other. So we could say that, rolling a dice would create some sort of uniform one. So every number comes out the same amount roughly. Okay, that's number 12. A little bit longer of a problem, but very interesting to think about different scenarios. It really makes you have to think deeply about what you're understanding. Okay, that's number 12. And moving on to number 13. So on number 13, we have these problems where we're going to actually be taking a look at measures of center and measures of deviation, or I guess variability rather, but basically the same type of thing here. So measures of center might be a little more review, and then mean absolute deviation might be the bit of new stuff here. So let's go ahead and take a peek and look at number 13 here. So for number 13, we have all of these observations here. So let's see, 4, 9, 3, 3, 11. So for observations, we'll say obs for observations, and there's going to be 3 observations. For the minimum, let's see, the minimum I think is 3, right? I think it's 3. And the maximum here, the maximum looks like 11. All right, the max is equal to 11. And moving on to the range. So how do you find the range? To find the range, we should just take the max and subtract the min. So 11 minus 8 is 11 minus 3 is equal to 8, so that would be the range here. And what else do we have to find? We have the mean and the median and the mode. I guess I forgot to do the mode, but that one's pretty easy. The mode here should be 3, if I'm not mistaken. I think there's 2 of them. Yeah. Median, we have to list the numbers from least to greatest or greatest to least. That's just the easy way to do it, is to order them. So if we do that, we would have 3, 3, 4, 9, 11. And if we were to cross these out on left and right, there's an odd number of numbers here. So this right here gets to be our lucky median or middle number, and it divides our data in half from like the lower and upper, okay? And so that's the median, and we can go on to the mean. The mean is going to be the average. So if we take the mean, we can just say 3 plus 3 plus 4 plus 9 plus 11. That's a sum of all of the digits, okay? And divide that by how many observations there are. There are 5. So adding up the top, we're going to get 20 plus 10 is 30. So that's going to equal 30 over 5, which is equal to 6. So our mean here is going to be 6, or that's the average between these numbers. Okay, that's the mean. And let's see here. I think we did all of them. 1, 2, 3. We have 7 things. Yeah, I think the last thing is going to be, let's find out or calculate the MAD. Okay, so for the MAD, this one's a little bit more time consuming, but the observations here, let's make a table. The observations are going to be 4, 9, 3, 3, 11. And to find the mean, or the average here, the mean we already know is 6, so don't do any extra work, just copy that down. That's the mean. And then we have to go ahead and subtract these to find our deviation. So we're going to subtract each of these values. And if we do that, we're going to, I guess I should label this. This is going to be our deviations. And so 4 minus 6 is equal to -2. That one's negative because it's below average. Then if you go ahead over here, 9 minus 6 is going to equal 3. That's positive because it's above average or above the mean. 3 minus 6 is going to be -3. That's below average again. Then we have 3 minus 6 again. That makes sense. It's just going to copy and say -3 one more time. And for this last one, 11 minus 6, we should get a positive value, which means it was above the average, above the deviation, above the mean, sorry. Okay, and let's go ahead and do the absolute deviation. For the absolute deviation, we just take the absolute value of each of these deviations. So the absolute value of -2 is 2. The absolute value of 3 is going to be 3. The absolute value of -3 is still 3. The absolute value of -3, we just did, is 3. And finally, the absolute value of 5 is equal to 5. Okay, so these are all the absolute deviations, the absolute distances from each of the points to the average. And so what are we going to do with these numbers? We're actually going to take them and we're going to average them together. So 2 plus 3 plus 3 plus 3 plus 5, that's a lot of 3's, all divided by 5. So 2 plus 3 is 5, 10 plus 3 is 16. I believe this is going to be 16 over 5, and if we divide that, that should be 3.2. Right there, there's our MAD. Okay, so for number 13, we went and we solved all of this. So on average, each of these mice are destroying 3.2 toys compared to the average number of toys that have been destroyed, or mouse toys rather. Okay, so there's number 13. So checking out number 14, 5 different middle schoolers chewed a certain amount of pieces of gum in a school week. So we have 0, 3, 5, 19, and 8. Okay, so right away with observations, I'm just going to abbreviate as OBS for observations. Looks like we have 5 different middle schoolers. I think we're told that, so that's nice and easy. From that, we can also go ahead and take a look at maybe the min and the max and the range. So min, max, range. The minimum, I guess there was one student who didn't chew any gum, and maximum, someone chewed 19 pieces of gum. For the range, we should just say, okay, the max minus the min, 19 minus 0 is equal to 19. That's going to be the range here. Okay. Going on for the mode. For the mode, it's the most frequent number, so I don't think any of these occur more than once, so we're going to say none for the mode. And what else do we have to find? Min, mode, max. Oh, median. That's usually the next one. Median, that's where you put them in order from least to greatest. So let's try 0, 3, 5, 8, 19. Those are the 5 numbers, I believe. And for the median, we're going to cross them off. We have an odd number of numbers, so we should have an actual median right in the middle. And it looks like we do have a median of 5 here. So go ahead and write that in as your median. Next, we have the mean. The mean is basically the average, right? So to figure out the mean, we can just add up all the numbers, which is going to be 0 plus 3 plus 5 plus 8 plus 19. And taking that sum and dividing it by the number of observations, or 5. So on top we have 8, 16, 35. This is equal to 35 over 5, and 35 over 5 is going to equal 7. So 7 is our mean, or the average. Okay, so now that we have the mean, we're going to go ahead and do the last part, which is the MAD. This one takes the longest, I know. It's a little bit tedious to do, so let's just get started. For the observations, again, I like making a table. It usually helps organize. Let's do 0, 3, 5, 19, and 8. Those are all our observations. And we can go and do our mean column. Our mean is going to be the average. So what was our average? I think we just calculated 7. So go ahead and write 7 next to each of these. That way it's easier to find our deviations, or how far each of them are from the average. So to go ahead and find these deviations, this was below the average, so 0 minus 7, that is going to be negative 7. Then over here, this is going to be a below average again, so subtracting 3 minus 7, that's going to be negative 4. Then subtracting 5 minus 7, that's again below average, so that's going to be a negative value, negative 2. This time we have a value that's above the average, so 19 minus 7 is going to be positive 12. And over here, 8 minus 7, that's above average one more time, so that's positive 1. So these are all our deviations, or how far each of the observations were from the average. Okay, so some were negative because they were below, and some are positive because they're above. And we can go ahead and find out the absolute deviations. All right, so to find the absolute deviations here, we're just going to take the absolute value of all our deviations. So we have 7 here. The absolute value of negative 4 is positive 4. The absolute value of negative 2 is positive 2. Absolute value of 12 is going to be 12. And the absolute value of 1 is just 1. So now that we have all of our absolute deviations, we're just going to take these and find the average of them, or the mean, which is where the whole mean absolute deviation comes into play. So we're going to take 7 plus 4 plus 2 plus 12 plus 1. And we should take all of those absolute deviations and divide by the number of observations, which is going to be 5 here. 7 plus 4 is 11, plus 2 is 13. 13 plus 12 is going to be 25. 25 plus 1 is going to be 26. And so we can write, okay, this is going to be 26 over 5. How many times does 5 go into that? It goes in 5 times, 0.2. So you can use a calculator, but just please write out the work. And you should be able to get that using long division anyway. But that's going to be a mean absolute deviation of 5.2. So on average, they ate 5.2 pieces of gum away from the average, which was 7 pieces of gum. So there you go. That's 14. All the 8 different pieces of information. Let's go on to 15. 15 says 10 different students wrote down how many slices of pizza they ate in the past month. 4, 5, 1, 7, 4, 5, 8, 2, 0, and 12. Okay, so that says 10 different students. So just getting started here for the observations. For obs, we can say there are 10 different people. And let's go ahead and write our minimum and our maximum and our range. And just do those 3 for now. For the minimum, looks like we do have a 0. And for the maximum, looks like we do have a 12. So for the range, we just have to do 12 minus 0, which is still 12. So the range is going to be 12 here. Pretty big range from 0 to 12, considering 12 is our largest value and 0 is our smallest value. So min, max, range. Now for the mode is the most frequent one. So what numbers come up more frequently than others? Maybe if I write them in order from least to greatest, it'll be a little bit easier. So we have 1. No, I'm just kidding. There's a 0 here. I'm going to cross out the 0. And then there's a 1. And is there a 2? There's a 2. There's 2 4s, it looks like. A 4 and a 4. 4 and a 4. And then We have 5 and a 5, 5 and 5, 7, 8, 12. Okay, so to find the median and the mode, mode, we have to see what is frequent here. So it looks like there's 2 4s and 2 5s. So the mode here is going to be 4 and 5. Okay, those ones are tied for first place, so they both get to be the mode. And now for the median. For the median, we can just find the middle number. So there's 10 people, so I should cross off. I guess I can do 4 on the left and 4 on the right. We have 2 middle numbers here, so if we cross those out, what's between 4 and 5? That's going to be 4.5, so directly in the middle. If that doesn't make sense, you could always take the 2 middle ones, add them, divide by 2. This is just finding the average, so this will be 9 over 2, or 4.5, 4.5. So our median here is going to be 4.5. That's the middle number dividing the data into an upper 50% and a lower 50%. Okay. Now moving on to the mean. The mean is just the average. So we can find that by adding up everything and then dividing by the number of observations. So what would the work look like? Well, we already have an order, so I'll keep that order 0 plus 1 plus 2 plus 4 plus 4 plus 5 plus 5 plus 7 plus 8 plus 12. So this would be the sum of all of them, and then we're going to divide by 10 at the end. So let's see, if we add up all these numbers here, 0 plus 1 is 1, plus 2 is 3, plus 4 is 7, plus 4 is 11, plus 5 is 16, plus 5 is 21, plus 7 is 28, plus 8 is 36, 36 plus 12 is 48. So I'm thinking here this will be 48 over 10. And if you divide that, I believe that's 4.8. So I think this is correct that the mean here would be 4.8. So if these 10 students ate different amounts of pizza, the average number of slices they all ate each is 4.8 slices. Okay, so there you have the mean for this problem set or for this data. And what are we going to do next? Well, we still have to find the MAD. So let's go ahead and give that a try. We'll go ahead with the observations first, I guess. Observations, we have, I'll go ahead and write them in order, I guess, again. That's fine. 0, 1, 2, 4, 4, 5, 5, 7, 8, and 12. Okay. And I'll go ahead and maybe I'll try to change up some colors here. So for the mean, we know the mean is 4.8 all the way down. 2 times, 3 times, I don't know why I wrote 4.4. 3 times, 4 times, 5 times, 6 times, 7 times, 8, 9, and 10. Okay, so these are all of the means, and we can go ahead and find our deviations. So deviations is going to be how far each of them are from here. So when we subtract negative 4.8, subtract negative 3.8, subtract negative 2.8, subtract here, negative 0.8, another negative 0.8, of 0.2, positive 0.2, should be 2.2, I believe, should be 3.2, and 7.2. Okay, so the ones that were below average get a negative deviation, and the ones above average have a positive deviation. So moving on, and let's find the absolute deviations. Okay, so that's where you take the absolute value of this negative 4.8, which is just 4.8. Absolute value of negative 3.8, it's 3.8. For this next one, we get a positive 2.8. Here, positive 0.8, another positive 0.8. Take this and write 0.2. Another one here, 0.2. Absolute value of 2.2 is just 2.2. Over here we have 3.2, and finally 7.2. Okay, these would be our absolute deviations. Finally, what do we have to do? we can go ahead and we can go find the mean absolute deviation by taking the average of all of these. So if we went ahead and took these values and found the average by adding them all up, I can go ahead and show you if we add them all up for the sum of the absolute deviations. If you think you add them all together, you get 26 over 10 different numbers. And let me just make sure. Yeah, I think it is 26. And dividing that by 10, that's going to be 2.6. So I know I kind of ran out of room earlier, but if I write this down over here, after all that work, the MAD, I believe, is equal to 2.6. Okay, so the average of the number of slices they ate was 4.8, but on average, they were 2.6 away from the average. That's what we just found out. Okay, 15 is now done, so let's check out 16. Looks like we have one more in this section where we have to figure out these 8 bits of information. So 8 different puppies ate a certain amount of treats in a day for being good boys. We have 2, 18, 15, 13, 10, 28, 10, and 8. Okay, so let's go ahead and write this down. So we have 8 different puppies, so we know our observations is going to be 8. We have 8 of them. And let's go ahead and do the min and the max. And we can do the range right after. So the min here, I don't know, maybe let's write them in order from least to greatest first. So 2 is the smallest, and then 8 is the next smallest. Okay, I think, yep, 10 and 10. Those would be the next two. I think we have 13, 15, 18. 13, 15, 18, and 28. So we had 8 different puppies. I still have 8 different numbers, but at least now it's easier to find the min, which is 2, and the max, which is 28. And finding the range is a little bit easier now that we have those. So 28 minus 2 is equal to 26. So 26 would be the range here. And after that, maybe find the mode. That's another frequent one that's easy to find. So for the mode, it looks like the 10s happen more than anything else. There's 2 of them, so the mode is going to be 10. All right. Once we have that mode, let's maybe go ahead and do the median. That median is going to be that middle number. So the median here, let's go ahead and cross them out. So we have 8 different people, 1, 2, 3, 4, 1, 2, 3, 4. So what's between 10 and 13? I do think it's 11.5, but if we weren't sure, we could take 10 plus 13 and divide it by 2. 10 plus 13 is 23 over 2, and that's going to be, 11.5. Cool. So the median here is going to be 11.5. Now for the more time-consuming pieces, we have the mean and we have the MAD. We can see if we can figure that out here. So to find the mean, we should find the average, which is adding up all the numbers together and dividing by the number of observations. So 2 plus 8 plus 10 plus 10 plus 13 plus 15 plus 18 plus 28. So that's the sum of all of the observations, and we have to divide that by the number of observations, which is 8. And so we have, 2 plus 8 is 10, plus 10 is 20, plus 10 is 30, and then that's 43, and that's 58, 60, was that 66, 76, 76 plus 28, 84, 104. Yeah, I think 104 makes sense here. So getting 104 over 8, and let's see, that is supposed to be, I think, 13. Okay, so 13 seems to be correct to me. 13 would be the mean. Okay, that's the average number of treats that each of these dogs got. Okay, 13. Now for the MAD. Well, let's go ahead and write our observations. We have 2, 8, 10, 10, 13, 15, 18, and 28. Those are the observations, and we can go ahead and do the mean. Mean is the average that we already found out, so that's 13. Just going to write it 8 times just so we have it next to it. Then finding the difference will tell us our absolute deviation. So we can put the deviations right here and then find the absolute ones afterwards. Here we should have negative 11. This is going to be negative 6, 7, 6, no, sorry, 5. This is going to be negative 3. This is again going to be negative 3. This is 0. This one is exactly on the average. This one's above average, so it's positive. This one's also above average, so it's positive 5. And 28 minus 13 is also positive, and that's going to be 15. Okay, so now that we have deviations, we should find our absolute deviations. And to do that, we just take the absolute value of these. So this is going to be 11 away from the average. Here we have 5 away. Here we have 3 away. And we're 3 away again. Now we're 0 away. 2 away. But on the higher side, that's 5 away and 15 away. We're again on the high end. Okay, so any positive deviations before the absolute value are going to let us know that we are in the positive side of it, or to the right. Okay, so going ahead and calculating the average of these numbers here, that would be the mean absolute deviation. So let's see, 11 plus 5 is 16, 16 plus 3 plus 3, that's 16 plus 6 is 22. 22, and then add a 0, 23, 24, plus the 5, it's 29, plus 15, 44, I'm getting. So this is going to be 44 divided by how many observations were there? There were 8 observations. 8, let's see, 8 goes into that 5 times with 4 left over, or 4 out of 8, so this is going to be 5.5, or 5.5. I guess it depends, right? So the MAD here should equal 5.5. There we go. All right, so 16 is now done. Let's maybe take a look at 17, where it says explain why the mean is a measure of center and while the mean absolute deviation represents a measure of variability. Okay, so let's give that a try. I think I'm actually going to type here just because it's going to be a little bit quicker. So I think that's going to just be a little bit more convenient at this time. So let's go ahead and let me see. Oh, I should change this to black so you can actually see what I'm typing. Okay, so mean is a measure of center. So the mean represents the average, which, let me make this a little larger, which should summarize a data set as being roughly the, I guess, center of the data set. Okay, so the mean is the average, and that summarizes the data set as saying, you know, the data is centered-ish around this number. So again, the average doesn't have to be the exact center. It kind of depends on the numbers, but the average gives you a general idea of where the middle is. So on the other hand, I'll say the MAD, or mean absolute deviation, represents the average deviation size of each observation, maybe, from the mean. So larger MADs represent that the data is more spread out, and smaller MADs mean that, I guess that's a little confusing to keep using the word mean, represents that the data is more concentrated. Okay, cool. So important thing to kind of understand here is that mean is just a number to summarize a data set and let us know where kind of the middle is. And once we know where the middle is, what we have here when we take a look at the MAD is just letting us know how far everything is from that middle number, or that average. Okay, so that's kind of the similarities and differences here between the measure of center, which is the mean, telling us where the middle is, and the mean absolute deviation doesn't have anything to do with telling us where the middle is, but it's just telling us how close together our data is relative to the middle. Okay, so that is number 17. All right, and let's check out the last problem that's before enrichment. So in 18, it says, in a few short sentences, explain the process of finding the mean absolute deviation. Okay, so here's a little text box. Let me type this one up as well. Let's kind of summarize this. Well, step 1, I guess you might be used to using a table, but what are we really doing in the table? Well, first we put them in columns so that we can find the deviations, right? We're just subtracting. So subtract each observation from the mean, or subtract the mean from the observation. It doesn't really matter, to be honest, to find out each deviation from the mean. Okay. Once we have that, we are going to find the absolute deviation by taking the absolute value of each deviation. Don't forget that when you have negative deviations, then you are below average, and positive deviations represent the fact that we are above average. So we have to go ahead and find those absolute deviations. And after that, we're going to do what? We're going to find the average of the absolute deviations. Okay? And once you have that, this will be your mean absolute deviation. Okay? So just keep in mind here that I kind of condensed it a little bit. You could find the deviations, then find the absolute deviations, but you could also just say find the absolute deviations. And you could do it in one step. You could just subtract and then, flip it if it's negative to make it positive and find the absolute deviation. That's also okay. But in a few short sentences, that's how you would find the mean absolute deviation. Okay, so there you have number 18, or the last required section problem in this section that you might have done. Okay. All right, moving on to part 4. So in part 4, we're going to do some enrichment type problems. And for 19, it says explain in at least 2 to 3 sentences what are some similarities and differences between statistical questions and non-statistical questions. So I don't know, I guess let's just use another text box here to type this in. So similarities and differences between statistical and non-statistical. So I could say something like, while both of these questions are collecting maybe information, they collect different amounts and can be used differently, right? So more specifically, maybe I'll say statistical questions are asked to collect data that can vary with multiple data points. So they're both questions. One of them has varying answers, and I guess we can say that non-statistical questions do not allow for that variation, right? So long story short, I mean, if you say like, how old are you? There's really one answer to that question if I'm asking you as in one person, but if we ask a whole bunch of people, then we create variation here. So they're both questions. However, one of them is going to be collecting a bunch of different data that we can look at and compare, but the other one is you ask one question and you can't really compare anything. So that's the maybe an example that you could have written here. Okay, so that's number 19. Let's take a look at number 20. Okay, so number 20 says, create your own statistical question and draw a dot plot for it. The shape of your data must be right skewed. With one sentence, explain how you can summarize your data knowing it is right skewed. Okay. So maybe for my statistical question, I'm going to say, how many mistakes did each person make on their math quiz, right? So that would be a statistical question, just because if we're asking multiple people, then we can collect data on it. So that's what the question I'm going to ask is, and we need to create a dot plot. So I'm going to go ahead and create something that looks like, well, actually, I don't know. The question doesn't say that we have to create one, but I guess, no, I'll just go ahead and sketch a rough one here. So if we have a number line kind of going across here, and mistakes on their math quiz, so I'll put 0, 1, this will be 2, call this one 3 and 4, 5 and 6. So everyone seemed to do pretty well, maximum 6 mistakes. Hopefully there were a lot of steps. So and it was going to be right skewed. If it's right skewed, that means most of the data is going to be on the left. So just so you can kind of see what this looks like. And if we say that most people didn't make many mistakes, that's a good thing, right? So if we go ahead and see what this curve would look like, maybe something similar to this, right? And so with one sentence, explain how we can summarize your data knowing it is right skewed. So what's kind of like a key takeaway or an observation you can make here? So let's go ahead and do that. So here, create a little text box. So it says, how can we summarize our data? We're basically saying most students made very few mistakes since the data was right skewed. If the graph was left skewed, then it would mean that most students made many mistakes. Okay, so hopefully that makes sense or is a good enough summary to convince you that if we make it right skewed, most of the data is on the left, and that is a good thing if we're talking about mistakes on a quiz or a test. Okay, so there you have number 20. All right, so on to 21. Create your own statistical question and draw a dot plot for it. The shape of your data must be left skewed. Write one sentence, explain how you can summarize your data knowing it is right skewed. I think I made a mistake with this wording, so let's call this left skewed. I think that only makes sense here, so sorry about that, little mistake. I must have just typed the wrong thing by accident. Sorry. So we're going to summarize it because that would be the opposite. So we can go ahead and take a peek and say the shape must be left skewed, so most of the data needs to be to the right. So let's create a statistical question where maybe we would expect the data to be on the right. So how many pieces of candy were eaten by a bunch of middle schoolers? Right? That would be a statistical question, asking a bunch of middle schoolers, right? And so not only that, we can say with one sentence. Okay, so I'm not going to draw it, but most of the data would be to the right. But so what can we say for maybe a conclusion or a summary? We can say that many middle schoolers tend to eat more candy than adults do, maybe, right? So we would expect most of the data to be to the right. And again, I'm generalizing here, so I'm just going to say, as I work with a lot of middle schoolers, they seem to eat more candy or enjoy eating more candy. Whether that may be always true, probably not, right? There's definitely some adults, including myself, that might eat a lot of candy sometimes, but maybe just from thinking about those that celebrate Halloween and like going to get candy, maybe those are people that do that. So again, not any of this is 100% true, but just an example. Okay, so that's 21. And taking a look at 22, 20 runners ran a 400-meter race and their times are shown below on the dot plot. Explain whether the shape of this distribution is left skewed, right skewed, or symmetrical, and state a conclusion about their times in general. Okay, so we can see here that this data is concentrated in the middle, just like this. We can see where the peak is. And let's go ahead and talk about like which shape this is. So okay, so what kind of shape is this? Is this left skewed, right skewed? Nope, this is let's type this in. This is a symmetrical, I can't spell at all, can I? This is a symmetrical distribution, okay? So most of the data is in the middle, so it's symmetrical. Let's state a conclusion just by looking at this. Well, we can say that most students ran between 84 and 86 seconds, right? That seems like it. A lot of people ran between 84 and 86 students. Most students ran between that time with the center in the middle. And as you get farther from 84 to 86 seconds, there are less and less time. So on the high end, it's rare for there to be very slow people, and on the low end, it's a little bit more rare to have very, very fast people. So, you know, they have your average here, and to be really, really on the high end of the spectrum or very, very low end of the spectrum, that's not a common thing that would happen. We would expect most people to be closer to the average in this case or this scenario. Okay, so what do we know about them? Most of their times are kind of just average in the middle, right? Most of their times are centered together in the middle around 85 seconds, right? Not a whole lot you can really say too much besides this, but we have somewhat of a normal distribution where everything's mostly in the middle, and it gets a little bit more special when you're on the high end or low end, depending on what you're looking for. Okay, so that is number 22. Awesome. Let's check out 23. On 10 different days, Benny, a puppy, performed some tricks for treats, and on each of the 10 days, he performed the following number of tricks. State the number of observations: min, max, range, mean, median, mode, and mean absolute deviation. Okay, so we're going back to working with this stuff, and so we have a good amount of work to do. So let's get into it. Okay, so for the number of observations, we have 10 different days, so that's going to be 10 observations. And if we go with the minimum, go ahead and write this in min, and go ahead and write max and range. Min, max, and range. So the minimum, it looks like we have 2 here, and the maximum I see is 35. 35 minus 2 is going to be 33 for the range. But just writing that out, that's just going to say, writing that work, 35 minus 2 is that 33. Go ahead and write that just like that. And if we take a look at the mode, let's see. I do see 2 4s. Maybe we'll just write them from least to greatest first. Makes it a little bit easier. So 2 is done. And then I see 2 4s, a 4 and a 4, cross those out. And then I do see 2 6s, a 6 and a 6, cross them out. And we have 14 and 25. And we have 28, 28, and 35. So 28, 28, and 35. So 10 different days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we just checked that out. And how many are repeating? So 2 4s, 2 6s, 2 28. So those are actually our modes, right? We have 3 of them. We have 4, 6, and 28. Those are going to be our 3 modes. Okay, they stand out the most here. And moving on, so we have the mode. Let's go over to the median. For the median, we have to list them in order from least to greatest, which we already did, which is great. And we can cross them off. So 10 different days, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And going right in the middle here, if we're going to find the median between, let's see, 6 and 14, they're 8 apart. So if you add 4, which is half of that, we're going to get 10. And if you weren't sure about that, you can also add the 2 middle numbers and divide by 2. That's going to be 20 over 2. That's also equal to 10. So we can confirm here that the median value is going to be 10. That separates the top half from the bottom half. Now, if we're going to go find the mean, for the mean, we're going to have to add up all these numbers and divide by 10, right? So we can go ahead and do that and say 2 plus 4 plus 4 plus 6 plus 6 plus 14 plus 25 plus 28 plus 28 plus 35, and divide that by 10, right? So let's see, that is going to be, I think, 152. 152 divided by 10, that's just going to be 15.2 because you slide the decimal over. So we know the mean here is going to be 15.2. Okay, so we have that, but here is the challenging part. The challenging part is then finding the mean absolute deviation. So what you can do here is you can then make a table and go ahead and find each of your deviations. So I'm not going to go through and show all that work. So, but if you get it correctly, then you can check it quite easily. You should get 11.04. That would be the exact mat. But again, you're going to have to find each deviation, just like I showed in problems earlier. But if you're doing the enrichment problems, I'm assuming you can see the process from earlier and make a table of your own. and you should come up with a MAD of 11.04. So on average, each of the amount of tricks is going to be about exactly 11.04 away from the average. That's the average deviation, average distance. Okay, so that is 23. Okay, moving on to 24. If we take a look at this one, we can really see what's going on with 8 different people are going to throw a discus in track and field meet. The distances were 58.3, yada yada. Okay, so we have all these distances, and what are all of these? Okay, and we're going to round all answers to the tenths column. Okay, so that way we don't have to deal with too many values. Yep, that makes sense. So for observations, how many people were there? There were 8 people. For the minimum looks like it's going to be 14.6. For the maximum, thinking 74.5. For the range, that's going to be 74.5 minus 14.6. And I think that's going to be 59.9. I think that's right. 59.9. Again, you can use a calculator, but we should write down the steps of how we found them. For the mode, I don't think any numbers really repeated themselves here, so I'm going to say none. Actually, I just noticed that this should say 18.3, not 18,3. So that was an accident. So if you thought those were 2 separate numbers, I apologize, but that's what I intended it to be. That would be a little strange. I think everything else is a decimal, so it makes sense there. And let's go with median. For the median, okay, we'll put them in order, I guess, from least to greatest. That seems like the right thing to do. And so 14.6 looks like the smallest. Then 19.5. Then, no, 18.3 first, right? 18.3, then 19.5. So we got those two. Let's go with 39.5 and 42.3. We'll go with 45.1, 58.3, and 74.5. Okay, I think I got those right. And there's 8 people, right? So 1, 2, 3 on the left, 1, 2, 3 on the right. And what's between these two numbers here? So this one's definitely a little bit harder to find the middle between these two. So this is where I typically just like to just take these 2 decimals and add them together using calculator and then dividing by 2. That should get you your average, which is right in the middle, and that would represent our median. So again, if we have 2 medians, then we would have to go in between them. So the median here should be 40.9 if I did this correctly. Hopefully I did, 40.9. And yeah, so let's do the mean. The mean is going to be the average. So the average, and I'm not going to write it out right now, but you can check your papers. How would you find the average? You would add up all the numbers that you do have here. And so if you add them all up and then you divide by how many numbers we got. We should be dividing by 8, right? That was the number of observations. So let's see here. Okay, so I'm not going to write out all the work for the sake of this particular video, but what you should get when you add them all up to find the mean or the average is 312.1. And if you divide that by 8, we're going to try to round this to the nearest tenth here. So it should be, well, it's exactly 39.0125, but to the nearest tenth, we're going to say this is about 39, okay? Just for the sake of making everything a little bit easier in this problem. And so when you find your deviations and everything, just use 39. Don't worry about using the exactly 39.0125, okay? So then if we do that, finding the MAD should be a little bit easier to do, right? Just because we have not as many decimals. So let's say you found all your deviations, you subtracted each of your observations from 39, which is the mean, then you're going to get all your deviations, you find the absolute value of them, and then you find your positive absolute deviations, right? And if you find the average of those, well, let's say if you add up all your deviations, you should get 129.3. That's if you add up all your deviations together. And if you find the average of them and divide by the number of observations, which is 8, we should get roughly 16. It's 16.1625, but if we round this to the nearest tenth here, we can say this is about 16.2. Go ahead and write that right over here. Okay, so if you are writing your MAD, 16.2, again, is it perfect? No, but I'm giving you just a real rough estimate here, and it's pretty accurate. Okay, it's pretty accurate. So I know the directions did say round the decimals to the nearest tenth, and that's what we just did here, 16.2. So on average, each of these people were about 16.2 away from the average. That's letting us know a measure of variability or how things are spread out. Cool. And so that wraps up this video on just going over each of the answers on this Unit 7 Homework 1 problem set. So hopefully it was helpful. And if so, let me know in the comment section below. And good luck, and I'll see you in the next one.